Welcome to Catalyst Medway, where we ignite understanding and make learning easier. In our today's class, we'll be looking at implicit differentiation under calculus. The implicit differentiation, it is a technique that is used to find the derivative of a function if the dependent variable y is not expressed explicitly in the term of dependent variable x. And the simplest shortcut you can follow or the steps you can follow while doing the implicit differentiation is that first you will differentiate each time. After differentiating each time, anywhere you differentiate y, you will put dy dx. After that, you will collect the like terms, those with dy dx to be in one side, those without dy dx to be in the other side. Then you factor out your dy dx, make it subject of the formula. That is a simple step you can follow to solve implicit. Also take note that during this implicit differentiation, while differentiating each time, sometimes might require you to use either the chain rule or the product rule or the derivatives of the trigonometric functions. Now let's solve this question briefly using implicit differentiation. The question one states that our x squared plus y squared equals to 25. And we said that the first procedure is that we will differentiate each time. Now, we're having three times here. This is the first time, the second time, and the third time. Now, differentiating x squared will give us 2x, then plus differentiating y squared will give us 2y. And we said anywhere you differentiate y, you put dy dx. So we're having 2y dy dx equals to differentiating any constant number will give us 0. Now, we'll collect the like terms, those with dy dx to be in one side, the one without dy dx to be the other side. So from here, we'll be having 2y dy dx will now be equal to minus 2x. From here now, we'll make our dy dx subject to the formula by dividing both sides by 2y. So here, we'll be having divided by 2y divided by 2y. So our 2y comes to 2y, we are left with dy dx equals to minus 2x all over 2y. These two can cancel 2. You are left with dy dx equals to minus x all over y. This is for the first question. The second question states that the second question is xy plus y equals to x squared. Now, we said we will differentiate each time. Now, for us to differentiate x and y, we should know that the x is multiplying y. So definitely we have to use the product rule to differentiate x and y. And how do we do it? If you're having x, y, this is our u and this is our v. And if you're having uv, the derivative will be u v prime, that is the derivative of v, plus v u prime, that is the derivative of u. Our u is already x and our v is already y. Then our u prime, that is the derivative of u. If you differentiate x, we'll be having 1. The same thing, our v prime, that is the derivative of v. If you differentiate y, you'll be having 1. Remember, we said that anywhere you differentiate y, you put dy there. So we'll be having dy dx. So the certain is here, we'll be having u, that is x multiplied by our v prime, which is dy dx, plus our v, which is y, multiplied by our u prime, which is 1, we'll still be having y. So this is the derivative of x multiplied by y. So bring it here. We'll be having x dy dx plus y, then plus, if you differentiate y again, we'll still be having 1. Remember, anywhere you differentiate y, you put dy dx. So we'll be having 1 multiplied by dy dx, which will give us dy dx. So we'll be having plus dy dx, which will now be equals to, if we differentiate x squared, we'll be having 2x. We'll collect the like times. Those with dy dx will come to one side. We can see from here that our x dy dx plus dy dx equals to 2x minus y. This y that is here. So from here, we can factor out dy dx. So our dy dx will now be into x plus 1. Because if you do dy dx multiplied by x, it will give us x dy dx. Dy dx multiplied by 1 will still be having dy dx, which will now be equals to 2x minus y. So from here, we can divide both sides now with x plus 1 so that we can make our dy dx subject of the formula. Our dy dx x plus 1 equals to 2x minus y. Divide both sides by x plus 1. X plus 1. This one cancels this one. We are left with dy dx will now be equals to 2x minus y all over x plus 1. So this is the derivative of xy plus y equals to x squared using implicit differentiation. Now to the third question. Third question, y equals to x squared plus 3x. The same thing, differentiate each time. If you differentiate y, you will be having 1. And we said anywhere you differentiate y, you will put dy dx. So 1 multiplied by dy dx will be having dy dx equals to, anywhere you differentiate x squared, you will be having 2x. So we'll be having 2x plus, if you differentiate 3x, we'll be having 3. So this is just the derivative of y equals to x squared plus 3x using implicit differentiation. The fourth question, question 4 said that our y equals to 5x3 minus 2x. Differentiate each time. If you differentiate y, you'll be having 1. And anywhere you differentiate y, you put dy dx. So you'll be having dy dx equals to, if you differentiate 5x raised to the power of 3, we'll be having 5 times 3x raised to the power of 3 minus 1. That will give us 15x raised to the power of 2 minus, if you differentiate 2x, we'll be having 2. So this is the implicit differentiation of y equals to 5x squared minus 2x. The last question here, question 5, is x squared plus xy equals 10. We'll differentiate each time. If you differentiate x squared, we'll be having 2x plus, if you differentiate xy, differentiate xy using product rule. We've already differentiated our x1 here and it gives us x dy dx plus y. So differentiating xy will give us x dy over dx plus y, which now equals to 10. So from here, we'll make our dy dx sort of the formula. We'll now be having x dy dx equals to, okay, sorry, anywhere you differentiate 10 or anywhere you differentiate any number, constant number, you'll be having 0. So our x dy dx will now be equals to minus 2x, if you move this one here, minus y. So from here, we can factor out dy dx and divide both sides by x so that we can be left to divide dx. From here, our dy dx will now be equals to minus 2x minus y all over x. So something using implicit differentiation, if you differentiate x squared plus xy equals to 0, your final answer will be minus 2x minus y all divided by x. So this is a shortcut or a simpler method for you to differentiate using implicit differentiation. It's not that hard, it's very simple once you follow the basic steps. Don't forget that even in implicit differentiation, anywhere you are differentiating each time, it might require you to use either product rule or the chain rule or any rule of differentiation. So and again, anywhere you differentiate y, you will put dy dx. That is a simple trick that you can use to conquer implicit differentiation. Kindly subscribe, comment, like, and share. Don't forget to turn on the notification bell so that you don't miss any new video.